Welcome back to Further Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the set of videos on vector geometry, and in this video here, the specific thing we're going to look at is finding a point, given that we know the line to that point is perpendicular to another line, which is part C here. But to begin with, we're going to have to crack out the rest of it. So as before, we've been given 2 points, A and B. We're going to have to find a vector equation and verify that a point is on that line. So we'll go through this at a reasonable pace. So as in the previous 2 videos, the first thing I'm going to do is write the vectors A and B in column form. So A is -14, 5, -1, and B is -8, 4, 2. Now I'm being asked to find a vector equation for the line AB. Which means that I need the direction vector A to B by doing -8, 4, 2 minus -14, 5, -1, which is going to come out as +6, -1, +3. And then I can use either of my 2 points. So I'm going to use the point A, -14, 5, -1, plus a multiplier lambda, and then the direction vector 6, -1, 3. And that is the vector equation for the line A to B. Now, part B then, we're given that the point C, which is P to Q. So I'll just jot that over here. C is the point P to Q. We're told that this lies on the line, and we're asked to find the values of P and the values of Q. So I'm just going to write out 3 equations. I'm going to write one in X, which is -14 plus 6 lambda equals P. One in Y, which is 5 minus lambda equals 2. And one for Z, which is -1 plus 3 lambda equals Q. Now we can probably see that straight away I can find here that lambda is equal to 3 from the Y equation, and then I can use that in my other 2 to find P and Q. So if I do -14 plus 6 lots of 3, I'm going to get that P is 4. And over here, if I do -1 plus 3 lots of 3, I'm going to get that Q is 8. So there you go, the values of P and Q. Okay, right then, part C, point D. The point D lies on AB. So let's get this line drawn here then. So here's the point A, and here's the point B. And D lies on AB. So here's the point D, such that O to D, so there's the origin O, is perpendicular to AB. Now, let's just remind ourselves of the equation that we wrote in part A for the line A to B, which was -14, 5, -1, plus lambda 6, -1, 3. Yeah, there we go. Now we're trying to find the coordinates of D. We don't know those coordinates yet, but we do know that D lies on the line A to B. So what I can actually do is I can define this point D using the equation of the line. So I can write that the x coordinate is -14 plus 6 lambda, that the y coordinate is 5 minus lambda, and that the z coordinate is -1 plus 3 lambda. And now these 2 vectors are perpendicular, which means there's going to be a dot product equaling 0 somewhere. Now I need the direction vector of this line from O to D, which I can just use this point here because it's relative to the origin. And I also need the direction vector of the line A to B, which I've got here in the equation. So what that means is that if I do the dot product of O to D, which is -14 plus 6 lambda, 5 minus lambda, -1 plus 3 lambda. If I dot that with 6, -1, 3, then that should come out as 0. So I can set this up to find lambda and then sub that back in to find the coordinates of D. So let's just set that up there. So 6 lots of negative 14 plus 6 lambda minus 1 lot of 5 minus lambda plus 3 lots of negative 1 plus 3 lambda is going to have to equal 0. So let's just take care of expanding this out. Negative 84 plus 36 lambda minus 5 plus lambda minus 3 plus 9 lambda is going to equal 0. So let's just collect those terms on here. So on the left-hand side, I'm going to say that I've got 46 lambda. And if I add everything else over to the right-hand side, I've got 92, which means that my solution for lambda is that lambda is 2. Now, crucially, that's not the solution. What I've got to do now is substitute this back into the point D to find my coordinates. So negative 14 plus 6 lots of 2, 5 minus 2, and negative 1 plus 3 lots of 2, which is going to give me 2, 3, and 5. So the coordinates of D are 2, 3, 5. So that point lies on the line and is the line O to D is perpendicular to A to D. Job done.